All right, so what are some other things that we might expect to find in alkanes? We already know that a basic alkane looks something like this, that being butane because it has 1, 2, 3, 4 carbons. So, and we also know that all of these carbons are single bonded to each other. Now, what would we call it, and what would we say if it's a simple carbon and hydrogen structure, but there was double or triple bonds? Well, it's actually really simple. If they have a double bond, they are called alkenes. They would look like this. For example, that right there representing the double bond. Drawn out, it would look like this. You can see that the double bond is between carbons 2 and 3. So the way that this works is just like any of the other endings, alkanes giving us a name like propane, butane, and then alkyl groups giving us a name like methyl, ethyl, propyl. Well, this works in the same way. The ending ene for alkene is going to just change the name from, let's say, butane to butene. Like that. All right, so, but for example, if I were just to say butene, how would we know on which carbon the double bond occurs? Well, just like any other substituent, we have to be specific. So in this case, where the double bond occurs in between carbons 2 and 3, we would say 2-butene, indicating that the double bond began on carbon 2. So this would be 2-butene. If I just said something like butene, then you would expect to see this. If you don't specify, what it means is that whatever it is that you are talking about, whether it's an alcohol group or a double bond or a methyl or ethyl group, if you don't specify which carbon it's on and there's only one of them, you assume that it is on the first carbon. So if I were just to say butene, with no specificity, we are to assume that the double bond occurs on carbon number 1, in between carbon 1 and 2. In this case, like I said, when it's in between carbons 2 and 3, we would call it 2-butene. However, let's say that, it was on carbon 3 and 4. If this double bond was in between carbons 3 and 4, you might think, all right, well, we can call that 3-butene. However, that would be incorrect because remember that IUPAC states that we are to assign the lowest number possible to the substituents that we are naming. If we call this 3-butene by numbering it this way, that would not be the lowest possible number you could give it, because if you numbered the chain that way and this became carbon 1, 2, 3, 4, that double bond would actually be occurring on carbon 1. So therefore, this structure would just be plain butene. All right, so triple bonds. The ending for that one is YNE, alkynes. And that just looks the same. You would have a triple bond like that, and it would be represented by something like that. So it works in just the same fashion as double bonds. And in this case, since it occurs on carbon 2, it would be 2-butyne. Just like that. The double bonding also can occur, well, anywhere, but it can also occur on cyclic compounds. So let's say we had cyclohexane, and we had a double bond right there. How would we name that? Well, the last name of this molecule is cyclohexane, and since the double bond is occurring here, and if we're numbering this molecule according to what we see here, we would start, let's say here, 1, and we would go around 2, 3, 4, 5, 6. Also keeping in mind that we want to try and assign the lowest number possible to the substituents. So if we chose to start, say, here, we would go clockwise instead of numbering it counterclockwise if we started here, just to make sure that the double bond goes in between carbons 1 to 2. So in this case, we just have cyclohexene. Again, there is no specificity on the number because the double bond occurs on carbon number 1, and the ending ene to indicate that there is a double bond. What might happen though if, let's say, we had a cycloalkane or a cycloalkene that maybe had 2 double bonds on it? How would we name that? And then this same rule can be applied to, if there's multiple double bonds, 2, 3, 4 double bonds, and the same thing for triple bonds. So let's say we had a double bond there and a double bond there. How would we name this? Well, we would basically use the same rules that we applied before with the multiple alkyl groups that I discussed in video number 2. So let's go around and number these. Starting here, 1, 2, 3, 4, 5, 6. All right, so the same thing, the last name of this molecule is going to be cyclohexene because there's 6 points and it's a cyclic compound. All right, so the first double bond occurs on carbon 1. It starts here. And the second double bond starts on carbon 4, right here. If we went around the other way, we would have to say that one double bond started on carbon 5 and the other one on carbon 2. Assigning the numbers 5 and 2 are larger than assigning the numbers 1 and 4. So we are going to go with 1 and 4. So we would write 1, comma, 4, and then dash. Now, how would we indicate? We already indicated by the ENE that there is a double bond. So just how you would say, if there was 4 methyls, you would say tetramethyl, 3 methyls, you would say trimethyl, 2 methyls, you would say dimethyl. Just in this case, if there's 2 double bonds, you use the prefix di, di. So, but it has to be inserted here before the ENE so that we know that we're referring to the double bond when we use the prefix di. So the name of this molecule actually becomes 1, 4, because that's where they begin, dash, cyclo, hexa, di-ene. And so that's how you would name that. You insert the di before the ENE, indicating that there are 2 double bonds. Also, just to kind of throw that in there, another type of substituent besides double bonds that you might find, and alkyl groups that you might find on alkanes, is halides. I'm just going to draw a butane here, write halides, and I'm just going to draw a butane like that. Alright, so a halide, of course, is found in the halogen group of your periodic table. That would be group 7, and it consists of fluorine, most commonly, fluorine, chlorine, bromine, and iodine. So that's, when we talk about halogenation in organic chemistry, that's really what we're referring to. So in the same way, you would just attach, let's say that's chlorine, like that, you would attach it like that, and when you number it, again, carbon 1, 2, 3, 4, and so just like you name any of these other things, the last name being butane, and the number upon which the substituent is 2 dash, and then we would just include the name of the substituent, in this case chlorine, so chloro. So this molecule would be called 2-chlorobutane. If it was fluorine, you would say 2-fluorobutane. For bromine, you would say 2-bromobutane. And for iodine, you would say 2-iodobutane. And that is simply how you name those. Thanks.